What?
For unit 6.4. Okay, 6.4, we're going to talk about something called relations and functions. Relations and functions. Okay, a couple definitions for you, because yes, you need to know these. Okay, a relation is an ordered pair. Okay, relation is just an ordered pair. A relation is an ordered pair. Okay, so any ordered pair is called a relation. A function is only when you have, only one y value for each x value. Okay, only one y value for each x value. So first part of what you're going to do for these is for number 1, I would like you to tell or determine whether the relation is a function. Okay, you have done this before. You've done this in Algebra 1. Okay, key thing that you want to ask yourself. Okay, you want to ask yourself. Are all of the x values different? Okay, because the technical definition of a function is a set of relations, so a set of points where there is only one x for each y. Okay, so basically, tell whether the function is a function. You can just ask yourself, are all of the x values different? Okay, so there's going to be a couple of these, and we're going to draw them. The A question is we're going to have those kind of weird, not parentheses, but brackets. And 0.12 as well as 1,3 in brackets. Sorry, those are really ugly brackets. Okay. B, so this is going to be kind of a multi-part question. The 0.24 and 3,4. For C, I'll give you a picture. And our picture is going to look very much like this.
Bless you. God bless you. Thank you. Taking those who far.
So I would like to know, tell whether the relation is a function. So basically any graph, okay, any graph is a relation because any graph you could label all the points. Okay, and a relation is just an ordered pair or a group of ordered pairs. Okay, so we want to know, is the relation a function for each of these? So these are going to be yes or no, basically. Give you guys just a couple minutes to get these all written down.
I think yes. Well, are A, B, C, D, and E all different problems?
Yes.
Okay, then no.
So we're basically doing, they're all, yeah, we're doing each in one individually.
Okay. Well, one is a no.
So for A,
Two is a
okay, is this a function? The point
No.
1, 2, and 1, 3.
No.
All you have to do is ask yourself, so if you have a list of points, you ask yourself, are all of the x values different? Or are the x values different in this function? No. Therefore, is it a function? This is a no. Okay, the A part is a no because you have the same value 2 times. Okay, for B, we want to look at the x values. Okay, the x values. Are all of your x values different?
Yes.
Yes. Therefore, it is a function. Okay, the y values can be the same, and these are, and that's fine. Okay, but we're looking for different x values as far as is it a function. For C, does anyone remember how to solve these? Anyone remember? How do you determine if this is a function?
Oh, you draw lines.
You use something called the vertical line test. Okay, for this one, you want to use what's called the vertical line test. And the vertical line test is basically if you draw a vertical line, which is vertical up and down or side to side. Vertical is up and down. Okay, so if you draw a vertical line anywhere, will it only touch one time? Okay, so if I drew a vertical line anywhere, if I drew a vertical line right here, does it only touch in one place? Yes. Okay, what about here? Yes. Is there any place that it would touch more than one place?
No.
No. So is this relation a function? Yes. Okay, it passes what's called the vertical line test. Okay, that means if anytime you draw a vertical line, it will only touch one time. Okay, what about this? This is the equation of a what? We just did these.
Parabola.
A parabola. Okay, is this an upward or a downward facing parabola?
Upward.
Upward facing. I don't really care if you draw it perfectly. This technically would be have a vertex at -1, -3, so it's going to look something like that. Okay. If you draw a parabola, does it pass the vertical line test?
Yes.
Yes. Okay. You can draw a vertical line, a straight up and down line anywhere, and it would pass. So is this a function? Yes.
So all parabolas are.
All parabolas are, yes. All parabolas would pass the vertical line test. Right? How about this? What does this look like? Looks very similar to a parabola, except the x and the y are switched. So this actually is a sideways parabola. We have not graphed those. Okay? All I want you to know is you don't have to be perfect on this. I just want you to graph a sideways parabola. So it would look basically like that. Okay, y equals parabola is up and down, and x equals parabola is side to side. So, is this a function?
No.
No, because anywhere you draw a line, this would touch two places. Okay, so there's some places on this graph that it would touch more than once. Therefore, it is not a function. Okay, so the first part is just determining, is this a function, yes or no? That's going to be the first part of your homework. The next thing you're going to do is, for example, number 2, I would like you to evaluate the following. Evaluate the following. If f of x equals 3x squared and g of x equals x plus 6. You guys okay if I move this up? Evaluate the following. If f of x equals 3x plus 6 and g of x equals x plus 6. Did I say the wrong? Sorry. F of x equals 3x squared. I think I like intermixed them. And g of x equals x plus 6. So basically, I'm giving you a formula. Okay, if it asks you to evaluate, all you're doing is plugging something in. Okay, so we're saying if you plugged in x, this would be your answer. Okay, if you plugged in x, that would be your answer. If you plugged in x, that would be your answer. So all you're doing is evaluating. So the A portion, I'd like you to evaluate f of -6. So all this means is use the f equation. So we're going to use this formula. Okay, instead of the g one, you're going to use the one that has the f on it. You're going to plug in this number in for x. That's all you have to do here. Okay, so f of -6 would equal, plug into here. So if f of x was equal to 3x squared, you just plug in where the x was. So 3 times -6 squared. How do I do 3 times -6 squared? What would be the first thing you should do?
Square this -6.
Square the -6. So 3 times what's -6 squared?
36.
36. then actually do the multiplication. So 3 times 36
108.
gives you 108. So for these ones, when I'm asking you to evaluate, all that means is plug into the right equation. That's it. Just plug into the right equation. Okay? The B one, I'd like you to evaluate g of 2x plus 1. G of 2x plus 1.
Oh, that's messed up.
So this is going to tell you to plug into the g equation. Okay, so the g equation, plug this into where x is. So if I plug that in for x, anytime you plug something in, remember you have to put it in what?
Parentheses.
Parentheses. So put into parentheses the 2x plus 1. We plugged in for x, then plus 6. Then you just, this one, nothing has to happen in front, so you can just drop the parentheses and combine like terms. So 2x plus 1 plus 6 would give you what?
2x plus 7.
2x plus 7. That's your answer. Okay, so all we're doing when I'm asking you to evaluate is just plugging things in. Okay, it is not supposed to be any more difficult than just plugging things in. I promise. Okay, and then the last one I'd like you to try, the C portion of this, is I would like you to evaluate f of 2x plus g of x plus 1. So this is a little bit more complicated, but not horrible. Okay, all this means is you're going to plug something in and plug something else in and then add it together. That's it. Okay, so we're going to plug in 2x into the f equation. So that means you would have 3 times, what am I plugging in? What do I plug in for the x?
2x.
2x.
No, yeah.
Right, we're plugging in 2x into this equation.
Squared.
Plus, plug into the g equation. So the g equation says we're plugging in the x plus 1 plus 6. Then you just have to work it out. Okay, so what would you do first here? Would you do the square or the multiplication? The square. So it would be 3 times, what's 2x squared?
4x squared.
4x squared. Plus, this one you can drop the bars. So x plus 1 plus 6, drop the parentheses, sorry. Then multiply this together. So 3 times 4x squared gives you 12x squared. Plus x, add these together, plus 7. You should write your answer in descending exponent order. So the largest exponent down to the smallest, or the one that doesn't have an exponent. That's your answer. That's it.
Oh, we don't
we're not
factor?
factoring.
Okay.
We're not solving. I just want you evaluating. So there is no factor and solving involved in this unit. None.
Awesome.
No factor and solve involved in this unit. Questions on how I did that so far? We're not quite done yet. Question? Dana? No? Okay, you guys all caught up on that, or are you still writing? I think someone said still writing. Who said still writing? Oh, okay. Next thing we're going to talk about is domain and range, okay? Hopefully you kind of remember these words because we've done stuff with them before. Okay, domain and range. Okay, does anyone remember what is domain? Not what's the answer, but what does domain tell you about?
If it's real or fake.
Nope. Domain has to do with what x can be. So the possible values of x. Okay, domain is what x can be. Range is the possible values or what y can be. Okay, so domain and range. Domain is talking about the x's. Range is talking about the y's. So for example number 3, I'm going to ask you to state domain and range. State domain and range of the following. When we were dealing with parabolas, yes, domain was always all real numbers. But we're not going to be dealing with parabolas anymore. So that idea kind of has to get out of your head. So state domain and range of the following. Okay, we're going to do 2 of them. The A portion, we're going to draw a graph. I'm going to go out 4 spaces in each direction. And on homework or a test, you will always have like a grid. It's going to be a nice grid. It's not going to be something that I randomly drew. So you'll be able to tell exactly where things are. So I'm going to draw a point here, point over here, one here, and here. So if I ask you to state domain and range, and you just have a picture, okay? If it's just a bunch of points, the first thing you need to do is label the points. Okay, so I'm going to label the points. So this point up here is supposed to be 1, 4. Okay? It's supposed to be 1, 4. If I didn't draw it perfectly, I apologize, but it's supposed to be at 1, 4. What point is this right here? 4, 1. So over 4, up 1. What point is right here? 0, negative 1. So over 0, down 1. And finally, this point is supposed to be negative 2, negative 3. So if you just have a bunch of points drawn on there, the first thing you want to do is label them. Okay? Then the domain is what? We said the domain is which variable?
X.
The x. The range is
Y.
the y's. So all you have to do for domain and range is you're going to draw kind of those weird parentheses, or not parentheses, sorry, the weird brackets, and you just label all the x values. It doesn't have to be in any certain order. You can start from the left, you can start from the right, you can start from the top, from the bottom. Does not matter. Okay? I just want to write down all the x values. So the x values would be what here?
-2.
So the x values are always the first ones, just in case we didn't know that. Okay, I'm going to go least to greatest. So x values would be -2, 0, 1, and 4. Close your little parenthesis things.
Hey, 2014.
This is true. Did not intend for that. Okay. The range is the y values. So if you just rewrite the y values. Okay. So the range is what? What are the y values here? -3. Then what?
1,
-1.
1,
+1.
and 4.
And 4. So domain and range, you're just writing down the x values, writing down the y values. That's it. If you have a list of points like this. The other situation that you'll encounter is if you have an actual graph. Okay, so if you have a picture, again, I'm going to go out to 4 in each direction. So if I go, I should have drawn these a little bit better. Okay, so if I draw a graph that starts at -2, -1, and goes till 4, 2. And it is solid in between. So here, do I have just specific points? No, you have a whole line. So first thing you want to do is label the ends of the line. Okay, so this end is supposed to be at -2, -1. Again, it will be on a nice grid so you could look at them like perfectly. This one is supposed to be at 4, 2. For these, we want to figure out what are the possible values of x. Okay, so the domain is the possible values of x. So if I listed every value of x, what would that be here?
4, -2.
Is it just 4 and -2 for the x's? Isn't there also a point right there? That's 0, right? I didn't list that, did I?
No.
Yeah, no, I didn't list that. So what do you think we have to do? Is it just -2 and +4? No. But it's what? Everything in between those, right? So how would you write every x value in between -2 and +4? Not -2 dash 4. But we want to, I want you to show that you know that these are x values. So basically every value between -2 and +4 should look like this. You have to write it as an inequality. So it includes -2, it includes +4, and every value in between. So every value of x between -2 and +4 is covered by this graph. Then you do the range the exact same way, but we're going to look at the y's. Okay, so y is sandwiched in between which values? -1 and +2. So we always do the smallest value on the left because we're doing less thans, the largest value on the right. Questions on how I did that? So that's domain and range. Domain is the possible x values, range is the possible y values. I still have one more. Okay, last one. Again, I'm going to ask you to, on this one, just state the domain. So just state the domain, okay? If you're stating the domain, what do we know about square roots? Okay, we're going to write some restrictions down. What do you know about the square root of a number? What cannot be underneath a radical if it's a square root? Cannot be negative, right? So if it can't be negative, how do you write that as an equation? What numbers are negative? All negative numbers. So how do you define a negative number? It's something that would be, cannot be less than what value?
0.
0. Okay? So nothing underneath a radical can be less than 0. Can it be equal to 0?
No.
Yes.
Wait, what?
Underneath the radical can be equal to 0 because you can do that problem. But you can't take the square root of a negative. Okay? The other restrictions you have is if you have a fraction and you have a numerator and a denominator. What do you know about if you have a fraction? Is it okay to have any number on the top of a fraction? Is it okay to have a negative on top of a fraction? Yes. Is it okay to have a positive on the top of a fraction? Yes. Is it okay to have a 0 on top of a fraction? Yes. 0 over anything just equals 0. So basically you can have all real numbers on the top of a fraction. What about the denominator of a fraction? Can your denominator be a positive number?
Yes.
Yes. Can your denominator be a negative number?
Yeah.
Yes. Okay, we're not taking the radical of it. But is it okay to have a negative number in the bottom of a fraction, like 1 over -3? That's okay.
But
is it okay to have a 0 in the bottom of a fraction?
No.
No. X cannot equal 0. Okay, x cannot equal 0. Therefore, if you have a fraction, the denominator cannot equal 0 because anything underneath 0 under would make your problem undefined. Okay, and that's bad. So for here, if I ask you to state the domain is just the possible values of x. Okay, for A, if I ask you to state the domain of f of x equals x over 6. F of x equals x over 6. Are there any numbers that you could plug in for x that would make you not get an answer here? Is there any number you could plug in for x? What if you plugged in -1? Is -1 over 6 an okay answer? Yes. What if you plugged in 0? 0 over 6 an okay answer?
Yes.
Yes, that's 0. Is a positive over 6 an okay answer? Yes. So are there any restrictions here for the domain for what x could possibly equal? No restrictions, therefore your answer is all real numbers. Okay, the domain for this is all real numbers. There are no restrictions as to what x could equal here. Okay, that would be all real numbers. B, I'd like to know what is the domain or the possible x values for h of x equals root x minus 3. H of x equals square root of x minus 3. What do you know about a radical? If you have a radical, it has to be what? Can't be negative, therefore whatever's underneath it has to be what?
S to be
Positive or equal to 0. So if you set that up as an equation, x minus 3 must be greater than or equal to 0. Okay, because it cannot be negative. So you have to set up anything under a radical to be greater than or equal to 0. Then how would you solve to give me an x value for your domain? Right, so x must be greater than or equal to what?
3.
Positive 3. Okay, greater than or equal to positive 3. So the domain is x greater than or equal to 3. Okay, and then the last one I'd like you to do for C is g of x equals 5 over x plus 7. 5 over x plus 7. Are there any restrictions when you have an x in the denominator?
Can't be 0.
It can't be 0, right? Therefore, x plus 7 cannot equal, that means cannot or does not equal 0. So what can x not equal?
Negative 7.
Negative 7. So x cannot equal negative 7. What I'm asking you for is what x can equal, though. Can x equal any number other than negative 7? So if I said any number, how do you write any number? All real numbers. So the actual domain here is all real numbers except negative 7. So that's how we write an exception. Okay, so all real numbers except x cannot equal negative 7. Okay, a lot of what you're doing on this unit is going to be involving functions. Okay, so you're going to be adding things together, plugging in, okay, finding domain. A lot of what this unit is dealing with is kind of the restrictions, okay, and knowing what x cannot equal if you have a radical. Okay, homework for this one is going to be worksheet 4. You are doing the odds, okay, all of them. So worksheet 4, you're doing numbers 1 through 36 odd. So I guess I realize that's really 1 through 35 odd. Okay, so you have 2 parts of homework tonight. One of them is worksheet